So how in the world does a massive company keep thousands or even tens of thousands of computers updated without, breaking everything or getting hacked? For a long time, it was just pure chaos. Today, we're going to pull back the curtain on how modern organizations have finally moved from that chaos to real control, and they're doing it with Microsoft Intune.
At the very heart of this entire challenge, there's this one fundamental conflict. On one side, you've got the security team, and they are demanding, absolutely demanding, that every single patch gets installed the second it comes out to close off vulnerabilities. But on the other side, you have the operations team. They need stable, predictable systems because they know that one bad update can bring the entire business to a grinding halt. So, do we really have to choose between the two?
Right, so that tension is the battle. It happens every single day in IT departments all over the world. And modern tools like Microsoft Intune, they're not about picking a side in that fight. They're about intelligently managing the conflict, especially when you're up against threats that give you absolutely zero warning.
And this is the stuff of nightmares for any IT team, the zero-day vulnerability. Think about it. The name says it all. It means attackers are already out there, actively exploiting a security hole before a fix even exists. It gives the good guys literally 0 days to prepare. And this is exactly why the old, slow, manual way of doing things just couldn't keep up anymore.
So how did we get here? How did we go from that manual, chaotic hellscape to this new world of automated, cloud-based control? Well, the story is really a journey, a move away from clunky on-premise servers to the incredible, intelligent power of the cloud.
For decades, the main tool for this was something called WSUS, or Windows Server Update Services. Now, I want you to just picture this for a second. You're an IT admin, and your job is to manually review, test, and then approve hundreds of individual little updates every single month. Our source material calls it onerous and a beast to manage, and they're not wrong. This process often led to these really dangerous delays, leaving companies wide open to attack while they were busy testing patches that were, frankly, already out of date. And this change represents a massive shift in philosophy. It's a totally different way of thinking. With the old way, WSUS, it was all about micromanagement. You were picking and choosing every little update. But with Intune, it's about macro management. You're not focused on individual patches anymore. Instead, you're strategically controlling the timing and the experience of the entire update process. It's a game changer.
Now, moving everything to the cloud was great, but it brought up a whole new fear, a big one: bandwidth. Think about it. If every single computer in an office tries to download a massive multi-gigabyte update from the internet at the same time, isn't that going to just crush the network? Well, the solution is this really elegant idea. You can basically think of it as carpooling for your network.
And just to put this problem into perspective, let's look at the numbers. To update just 1,000 PCs with a single 4 GB feature update, you would chew through 4 terabytes of internet data. 4 terabytes. For any company, especially one with lots of offices, that is just not going to fly. It's a huge problem that absolutely needed a clever solution.
And that brilliant solution is called delivery optimization, and it works exactly like carpooling. Instead of 1,000 computers all driving to the internet to pick up the exact same file, one computer makes the trip, downloads the file, and then shares it with everybody else in the office over the super-fast local network.
The process is beautiful because it's both incredibly simple and totally secure. So the first PC, let's call it PC A, grabs the update from the cloud. Then when PC B needs it, it doesn't go to the internet. It just kind of shouts out to its local neighbors, "Hey, anyone got this file?" And PCA says, "Yep, right here," and shares it directly. And here's the crucial part, the security layer. Every single piece of that file is digitally signed by Microsoft. So even though you're getting it from your neighbor, you know with 100% certainty that it's the real deal and hasn't been tampered with.
Okay, so bandwidth problem? Solved. But what about that other big fear? The risk. How do you actually roll out an update to thousands of machines without accidentally breaking some critical business application for the entire company? Well, you do it in carefully controlled phases, or what we call rings.
The philosophy here is really simple, and it's based on humility. You have to admit that you can't test for everything. It's impossible. Your real-world production environment is always going to have some weird software or strange configuration you just didn't account for. So instead of a big bang deployment where everyone gets it at once, you use these rings to limit the blast radius. If something does go wrong, it only affects a small, controlled group, not the whole company.
And this is what that looks like in practice. Updates always start in the very center with Ring 0. That's a tiny, tiny group of IT pilot users, people who know what to look for. If everything looks good with them, the update moves outward to the broader IT department, then to a larger group of volunteer early adopters from across the business. And only after weeks of successful validation does it finally, safely reach the general population.
So what's the secret sauce that makes these rings work? It's all about a simple setting called the deferral period. You can see here, Ring 0 gets the update immediately, a 0-day deferral. But Ring 1 is configured to wait 7 days, and the general population, they wait a full 14 days. This simple automated time delay is what creates those crucial safety gaps, giving you time to watch, listen, and spot any problems before they can impact the entire organization.
But, sometimes a schedule just isn't enough. There are situations where you need absolute total control. Sometimes you need to slam on the brakes, and other times you need to stop on the accelerator. And for that, Intune gives you two very, very powerful tools.
And this control really boils down to two key tools. First, you've got the lock. This lets you use a policy to freeze devices on a specific version of Windows, say 22H2, and they will not move past it. This is absolutely essential when you have critical line-of-business apps that you know are only compatible with that one version. Then you have the exact opposite, the panic button. This thing overrides all your rings, all your schedules, all your deferrals, and it forces a critical security patch onto every single machine, right now.
And I gotta tell you, that panic button is not something you press lightly. As the source material explicitly warns, this can and will force people's computers to restart, even if they're right in the middle of the workday. This is a tool you reserve only for those genuinely critical 0-day emergencies where the risk of getting hacked is way, way bigger than the risk of disrupting someone's workflow for a few minutes. So, when you step back and look at the whole picture, what's the big takeaway here? Modern update management, it's just not about clicking approve on a long list of patches anymore. It is a fundamental strategic shift. You're moving away from that reactive, manual grind and toward a proactive, automated system that gives you precise, granular control over timing, risk, and ultimately the end-user experience.
And that really gets you thinking, doesn't it? If we can automate something as complex and as high stakes as operating system updates this intelligently, what other parts of IT management are next on the list? Where does this level of proactive, smart, automated control go from here?